You're not audible. I can't hear you.
Hello.
Now you're audible. Hello. Rajesh, I can hear you. Can you hear me? Can you hear me, Rajesh? I can hear you.
Yeah, I can hear it, sir.
Uh-huh. So we will start the
I am
class.
from chemical engineering.
Uh-huh.
So when will the classes start?
So we will start, I think, around, let's wait till 7:05.
So which subject will you teach, sir?
I will be teaching heat transfer.
Heat transfer.
Uh-huh.
Any of the topics has been started, or sir, this is the first class?
So what we will do in this class is we will be solving the previous year questions.
Okay.
So last year we had take a look at
Sir,
couple of
from which year?
no. So we will be solving the GATE previous year questions. So I don't think heat transfer.
Yeah. Sir, which year?
No, so heat
Which year
trans.
question we will be solving, sir?
No, so have you done the heat transfer course?
Yeah.
So heat transfer is in some colleges it is taught in second year, in other colleges it is taught in third year. But we will be taking a look into the entire
Sir, I,
subject of
I am
heat transfer.
passed out.
So
Sir,
heat
I have passed my BTech, sir.
फिर तो ठीक है ना. Heat transfer you would have basic idea.
I have completed the syllabus of GATE, sir. I want to practice more.
So I don't think for chemical, I think on the GATE portal we haven't uploaded the mock test yet.
Yeah, I was searching there on the website
No,
and I was not able to find the same.
no. So I think it will take a bit of time for GATE chemical engineering for the mock test.
Uh, and heat transfer, sir, which year question paper you will be discussing, sir?
Acha, year. So last time we discussed, I think 2007, but now we will be going from 2022 to 2021. We will be going backwards.
Uh, okay, sir, I will be joining there.
Uh-huh. Okay.
I will try to see what
Mhm.
are the things that I have
Mhm.
memorized or what are the concepts I have learned till yet
Mhm.
so that I can.
Mhm. Good evening, Deepak. Good evening. No need to do all this formalities, चलेगा सब.
Okay.
Hello everyone. Good evening. I'm Rahul Patel from Department of Chemical Engineering, IIT Bombay, and I'm a Prime Minister's Research Fellow category. And this session on every Tuesday 7 to 8, we are conducting to solve the previous year GATE questions. So in every session, just wait a minute. So sorry for the disturbance. Uh, So in this session, we will be solving previous year GATE questions. So in every session, we will be taking around 4 to 5 questions, and we will be solving those questions from the scratch. So if there are any basic main concepts that needs to be revised, that we can revise it. Meanwhile, if you have doubts in any of these questions, you can ask. So I will be playing video recordings of the questions that have been solved, and and we will be discussing it, and later on all these recordings will go on the GATE NPTEL portal. So from GATE NPTEL portal, I can just show it to you, that portal. Mhm. So this is our NPTEL GATE portal. Okay. And the objective of the portal that we have developed is to provide a comprehensive one-stop solution to all your GATE related queries. Okay, so there will be concept videos on this as well as the solution of the previous year questions. So right now for chemical engineering, we don't have any of those things in this portal. So we are developing on that. And basically this live interactions are to complement those video solutions as well as GATE syllabus mapping. Also, this GATE practice test for chemical engineering will take a lot much time as compared to other departments that have been available. Yes, that was the introduction, and I think we can start in a couple of minutes once few of the students have arrived. I guess we can start the session right now. So can any of you just introduce yourself? So what are your expectations from this session, and a bit about background, in which year are you studying from, maybe from which college, what all subjects have you studied? Can any one of you or couple of you can introduce themselves so that I know what's your status related to all these courses? Maybe Praveen, Priya, Ritika, Sneha. You can unmute yourself and speak up. Am I audible?
Yes, sir.
So you can just introduce yourself. What are your expectations from this session so that we can deliver better?
Yes, sir. Good evening, sir, and all my friends here. My name is Digvijay C. Kadu, and I am final year chemical engineering student studying at Dharamsi Desai University, Nadia, Gujarat.
Okay.
Uh, I've been following NPTEL for quite a few years now, and the name itself has a big impact on the entire engineers community or MSc student community. So when first I learned about the sessions that NPTEL is going to take live mentoring sessions, I was very happy.
Mhm.
And I would, on behalf of all the students, I would like to thank NPTEL for that. My
Mhm.
expectations from the session are that I would get better insights of the GATE examination. How would I be able to score better with efficiently? Because
Mhm.
I appeared in year 2022 as a third year student. I also qualified. I also got a rank of around 1400.
Mhm.
But when I saw my paper, I was actually working at only 50% accuracy.
Mhm.
Means questions, I have attempted around 40 questions and I have only got 22 questions right.
Mhm.
So I am expecting to increase my accuracy. I would like to know from the professors of IIT and very dignified persons in the field of chemical engineering that how can I improve on my
Mhm.
strategy and accuracy. So looking forward to all these sessions and thank you very much.
Okay. So the key to acing any exams is the more you solve the questions and the more you do the practice, then you will get a good hold of the concepts that have been involved. So that is why we are we are doing this activity. So on the NPTEL portal itself, you can find the links related to this course content that are linked with the NPTEL videos of that specific course for chemical engineering that we are working on that. But in live interaction, we can discuss those concepts as well. So to give a background of mine, I did my bachelor's in chemical engineering from NIT Surat in around 2016, and now I'm doing my PhD in chemical engineering department at IIT Bombay. So with GATE, you can either opt to join public sector undertakings that are PSU companies, as well as you can opt for MTech or PhD position straight away from BTech to join the research programs in the IITs, NITs, all those institutes except the GATE score. So let's just start solving the questions. Let's try to keep this session interactive, not one-sided. So just to give a brief of the just give me a minute. Mhm. So in the past class, we had looked upon, I guess, 4 questions. So the first one was related to the radiation view factor. The other one was this normal heat balance equation across the wall. third one was related to this flow across a thin walled tube. Again, that introduces this concept of log mean temperature difference. Then the last question was again this heat balance across a stirred tank vessel. So these were the questions from GATE 2007, and today we will be looking at GATE 2022 paper. Okay, so let's just start. I will just read the first question that we will be solving today from the GATE. So this question is from GATE 2022. GATE 2020. So this is from GATE 2022 paper, chemical engineering paper, and the subject is heat transfer. So we will try to solve all the questions of heat transfer within the couple of weeks, and then we can move on to other subjects. And this is question number 30. So you can find all these past year questions papers on the GATE portal, not the NPTEL portal, but on the specific GATE portal. So the first question we will be solving is a perfectly insulated double pipe heat exchanger is operating at a steady state. Saturated steam enters the inner pipe at 100 degrees Celsius and leaves as saturated water. Okay. So from this part of the question, you can see that we are having a double pipe heat exchanger. And now saturated steam is entering from here. So let's just call it as the temperature is TH of steam. Here the steam changes into water. So basically the steam condenses into water and the latent heat is used for heat exchange. And again, cooling water enters the outer pipe at 75 degrees Celsius and exits at 95 degrees Celsius. So let's say cooling water inlet is at 75 degrees Celsius and TC outlet is 95 degrees Celsius. And we have been given overall heat transfer coefficient as 1 kilowatt per meter square Kelvin, and the heat transfer area is 1 meter square. The average specific heat capacity of water is given. This is Cp. The required cooling water flow rate. So we have to find the mass flow rate. So the basic concept in most of this heat transfer problem will be you will be using the heat balance. So you will be equating the heat exchange by the hot fluid to the heat exchange across the surface or the heat gained by the cold fluid. So that is how we will be solving most of this heat balance equation. So, but just by reading the question, does anyone want to discuss anything, how we would solve this question or any doubts related to this question? You can unmute yourself or maybe write in chat box also if you have any doubts. Okay, so since there are no doubts, I will show you the solution to this question. Just let me know if the volume is a little less. Okay. Hello everyone. Today we will be solving question number 30 of the
NPTEL videos as well as their modules.
Uh, am I not audible? Can anyone speak up, or is the volume too less?
Then that
Okay, so we have solved the first question number 30. So has anyone if anyone has any doubt in this question or the solution, then they can speak up and we can discuss it. Course relevant materials can be found out in both of these two links. So this second link is, I guess, web lectures, and these are the video lectures. Anyone is having doubt? Or else we can move to the next question. One more thing. So here, this was a numerical answer type question. Okay, so they had asked to round off to two decimal places. So if you round up this to two decimal places, then the answer range will be, I think, 0.14 to 0.15. So your answer should lie within this range. Okay, since this was a numerical answer type question. Now let's just look at another question. So I'll just quickly read the question, and in the video you can just see the details of that question again. So consider a bare long copper wire of 1 mm diameter. Its surface temperature is Ts and ambient temperature is Ta, where Ts is greater than Ta. The wire is to be coated with a 2 mm thick insulation. The convective heat transfer coefficient is 20 watt per meter square per Kelvin. Assume that Ts and Ta remain unchanged. To reduce the heat loss from the wire, the maximum allowed thermal conductivity of the insulating material is in watt per meter per Kelvin rounded off till two decimal places is. So again, this is my numerical answer type question, and we have to answer till two decimal places. And see, if in heat transfer question, if you find any question uh, related to this insulating material and this heat loss, then it will be based on the topic of the critical thickness of insulation or critical radius of insulation, whatever you call it. Okay. So in this specific question, we are considering a cylindrical system. Okay, so this is my wire and this is my insulation. So we have been asked to find the thermal conductivity of material such that it reduces the heat loss from the wire. So this heat loss will be maximum at my critical when the critical radius of insulation is Rc, and below that the heat loss will be minimum. So we have to find this K for which Rc is which is close for which this condition is satisfied of this critical heat of insulation, critical radius of insulation. Okay, so let's just play the video solution. Okay, so in this question, we discussed the concept of critical radius of insulation, and then we solved this question to find the thermal conductivity of the insulating material based on critical radius or thickness of insulation. If you have any doubts, you can just ask it. Or else we can move to another question. So these are the basic formula. You can see the derivation over here also. So basically, we'll be equating this. We differentiated that heat balance, this resistance heat balance equation, and equating that till zero, we will be getting the critical thickness of insulation as K by H. So you don't need to derive all this. You can just straight away remember that formula. That for sphere it is K insulation upon H. So just make sure that remember that K is for insulation, not the material. Many times to confuse, they will be also providing the thermal conductivity of the pipe. So you need to consider the thermal conductivity of insulation, and the H will be for my ambient air. The formula for critical thickness of insulation will be K by H for cylinder, and for sphere, similarly you can derive it, and it will be 2K by H. Let's look at the third question. I'll just straight away play the video. So just to give an idea, So I have provided the links of this question in the below, so you can just click, find those links. Okay. So here you can see we are having lecture 32 of heat transfer. So you can just, if you just move to lecture 32, so here you will find the concept related to radiation shield. So in this specific question, we will be using this concept to solve the question. Okay. So let's just play the third question. Hello. We will be solving question number 41. So if you have any doubts, you can ask or write in the chat box. In this question, we discussed about the concept of the radiation shields. So do you have any doubts, anyone? Okay, so we will move on to the last question for today's session. So this is question number 54 from GATE 2022 paper, and it is related to the film, that is basically extended surface part of the heat transfer area.
Hello everyone. We'll be looking at question number 54 of the 2022
So we have solved this question related to a cylindrical fin attached to a wall surface based on this fin effectiveness. So if anyone has doubt, they can speak up. We won't be taking any more question today. So this was our last question. If you have any of doubts related to the subject in general, also you can ask, and maybe we can discuss it next time. If there are specific questions that you need me to look upon, then also you can just inform, and I can do it in the next time. If you want to contact me over email, you can do it. I will just write my email ID over here. Just wait a minute. So this is my email ID. If you want me to solve any specific question related to heat transfer or any subject, or in general, if you have doubts related to any of this concept, you can just write it on this email and we can consider it in our next class. Also, so we are recording this video, and the slides also will be available on the NPTEL portal. So right now we are working on it. So basically we'll find all these slides as well as the video recording of this session on that NPTEL portal. Again, so all these video recordings will, so we will be creating a section for this chemical engineering department, and in that section you can find this year wise or topic wise solution of each of this question. So that is our main task behind carrying out this interactive session. So if you have any doubts, you can just speak up and we can discuss it. I would expect that this session to be more interactive. So next time maybe I will try to make this more interactive by taking the inputs from the attendees. So if not, then we can end the meeting in, let's say, five minutes. I will wait for 5 minutes. If you have any doubts, then you can ask it.
Sir,
Yes, Deepak.
sir, there is a doubt, sir.
Uh-huh.
Sir, in our portal there was only Monday and Tuesday we have sessions.
Yes,
Remaining days,
for chemical engineering, we right now only have 2 students working on it. So the sessions will only be twice a week.
okay, sir.
Mhm. Do any of you have any doubts, or else I can end the meeting? Okay. So I think I will end the meeting. Thank you everyone for attending.
Thank you, sir.
Okay. Bye everyone.
Thank you, sir.